I wanted to do an example of drawing orbital diagrams and determining electron configurations. So I'm going to start with nitrogen because it's a fairly simple example. Has an atomic number of 7 on the periodic table. So nitrogen has 7 electrons. Alright, so if we're drawing an orbital diagram, what I always draw first is I draw the y-axis, which is energy. So I'll just label that E. So it's really important in chemistry that you're always labeling what you're talking about. So this is our energy axis. And remember that our lowest energy orbital is our 1s. And then our 2s is much higher in energy. And then we have our 2p. Okay, so if we're filling up, if we're drawing this orbital diagram, we need to follow the Aufbau principle and Hund's rule. So we have 1, 2 electrons in our 1s, 1, 2 electrons in our 2s, and then 1, 2, 3 electrons in our 2p orbital for a total of 7 electrons. And if we're to draw out the electron configuration, it's almost exactly the same as doing the orbital diagram. It's just going to be 1s2, indicating that we have 2 electrons in our 1s orbital, 2s2, 2 electrons in our 2s orbital, and then 2p3. Alright, so it's really important that you understand that this is our orbital diagram for our electrons for nitrogen, and this is our electron configuration. So you really need to be able to draw both of these properly for this class. So we talked a lot about the Aufbau principle and Hund's rule and the order that electrons fill and how it's all based on quantum numbers and the solutions to the Schrodinger equation. So I just wanted to tie this into the current organization of the periodic table is just based on the Aufbau principle, which is based on the solutions to the Schrodinger equation or our atomic orbitals. So we know that our 1s orbital fills up first, so it's our first 2 elements on the periodic table have electrons in the 1s orbital. And then we have lithium. Lithium has an electron configuration of 1s2, 2s1. Beryllium is 1s2, 2s2. And then when we get to boron, carbon, nitrogen, oxygen, these are in our p block because now this introduces electrons into the 2p orbital. And so you can see that the periodic table is literally just set up in the fashion that the electrons fill in according to our solutions to the Schrodinger equation and the Aufbau principle. So we have an S block, a P block, and a D block, and also an F block. So this is our periodic table. Something that I wanted to point out is that a noble gas configuration, so when you have a completely filled sublevel, such as neon, where you have 2 electrons in your 2s orbital, 6 electrons in your 2p orbital, so all of your sublevels are completely filled, this is the most stable configuration that you can have. So these are our noble gases, and they're not very reactive at all because they have such a stable electron configuration. Okay, so since we know that noble gases have such a stable electron configuration, it's really important that we understand which electrons are participating in reactivity. So we know that these elements are not very reactive, but some elements are. So we need to talk about categories of electrons. So inner electrons, or core electrons, are those an atom has in common with the previous noble gas and any completed transition series. So for example, if we're talking about lithium, lithium has an electron configuration of 1s2, 2s1. So its inner electrons are its 1s electrons. Outer electrons are those with the highest energy level or highest N value. And outer electrons are almost the same thing as valence electrons. So valence electrons are the electrons involved in forming compounds. So for main group elements, valence electrons are the same thing as outer electrons. The only time outer electrons and valence electrons differ are for transition elements. So for transition elements, your valence electrons include the outer electrons and any n-1d electrons. So the valence electrons for our nitrogen example are our electrons with the highest principal quantum number, which is 2. So our 2s and our 2p electrons are our valence electrons. So we have 1, 2, 3, 4, 5 valence electrons for nitrogen. So these are the electrons that are involved in bonding. And the inner electrons are electrons that we have in common with the previous noble gas, which is helium. So the 1s2 are our inner electrons. So I'm just going to write this out, that this is our inner. So these are the ones that are involved in bonding, which is really important.